The third numerical consists of two clay specimens, one is A and one is B, of thickness 2 cm and 3 cm. Have equilibrium void ratios as 0.68 and 0.72 respectively under a pressure of 200 kN per meter square. If the equilibrium void ratios of the two soils reduced to 0.5 and 0.62 respectively when the pressure was increased to 400 kN per meter square, find the ratio of the coefficients of permeability of the two specimens. The time required by the specimen A to reach 40% degree of consolidation is 1/4 of that required by specimen B for reaching 40% degree of consolidation. So there are two soil samples of A and B having various thickness, various void ratios. So hence we will compare the two values and we have to find out the time required by the specimen A to reach 40% degree of consolidation. And the relationship is given as the time is given for the A is 1/4 that required for the B for achieving same degree of consolidation. So let us provide the different subscripts as A and B for two different type of soil. We know that the formula for coefficient of volume change is given by mv equals to minus delta A divided by 1 plus E naught multiplied by 1 by delta sigma. So for soil A, initial void ratio is 0.68, final void ratio is 0.5. Hence the change in void ratio will be 0.5 minus 0.68, that is minus 0.18. The increment in pressure will be 400 minus 200, that is 200 kN per meter square. Again for soil B, the initial void ratio is 0.72 and the final void ratio is 0.62. Hence the changes in void ratio will be 0.10 and the change in pressure will be 400 minus 200, that is 200 kN per meter cube. So substituting all this value and finding out the coefficient of volume change for A sample and B sample, we are getting that the coefficient of volume compressibility for sample A is 0.536 meter square per meganewton, and for MV, for the value of the soil V, it is given as 0.291. So this value we are obtaining for sample A and sample B, and when we are finding out their ratios, their ratio will give the value 1.845. And again, if we know that if the sample have the same degree of consolidation, then if we make a ratio of their timing to consolidate, so for the sample of the soil, TA and TB will be equal to DS square by TB square multiplied by CV into B by CV into A, where D is the depth of the sample and CV is termed as coefficient of consolidation. So for finding out the ratio of the coefficient of consolidation, we could write that TA square into TB divided by TB square into TA. So where the depth of the sample can be given as 2 divided by 2, as the depth of the sample is 2 cm thick and depth of sample B is 3 cm thick, and there are drainage in both direction. Hence this 2 by 2 and 3 by 2 whole square, and time required for sample B is 4 times that of sample A. Hence the time will be 4 by 1. Hence we are getting the ratio as 16 by 9. So if we want to get the ratio of the coefficient of permeabilities of sample A and B, we can easily substitute in the equation CVA into MVA divided by CVB into MVB, as the unit weight of water is common in both the cases, so we are not writing the value of the unit weight of water. So substituting their value 16 by 9 multiplied by the ratio of the coefficient of volume change as 1.845, we are getting the coefficient of permeability ratio at 3.28. So we are getting the value of the coefficient of permeabilities of the two samples from this relationship. So let us proceed to the last problem. What has been provided here? An untested sample of clay 24 mm thick consolidated 50% in 20 minutes. When tested in the laboratory with the drainage allowed at top and bottom, the clay layer from which the sample was obtained is 4 meter thick in the field. How much time it will take to consolidate 50% with double drainage? If the clay stratum has only single drainage, calculate the time to consolidate 50%. Assume uniform distribution of consolidation pressure. So here it has been provided, same degree of consolidation has been given, and for same degree of consolidation the time factor will also be same. So hence the time for consolidation will be directly proportional to the depth of the soil sample divided by coefficient of consolidation. So for the same case where double drainage is occurring, so the formula will be T2 by T1 equals to D2 square by T1 square. Why this formula? Because if the clay layer is same, then coefficient of consolidation will also be same. Only the depth and the time will vary. So for D2, the depth of the drainage path will be equals to 4 by 2, as it is double drainage, that is 200 centimeter, and for the drainage path 1, it will be 2.4 divided by 2, that is 1.2 centimeter. And the time required for 50% consolidation in the laboratory is given as 20 minutes. So hence for the second time, what we will do for the field time interval, we are getting T2 equals to T1 into D2 by D1 whole square. So substituting all this value, we are obtaining T2 at 386 days. Next, for the case of single drainage, so in case of single drainage, what happens? We do not multiply the drainage path with half, because the water can flow in one direction only. In case of double drainage, the water can move from top as well as bottom. Hence, the depth of the soil or the thickness of the sample get halved. Hence, for the single drainage, we will consider the full depth of soil. Hence, the T2 will be changed to 4 meter or 400 centimeter, and the depth of the drainage path in laboratory sample will be same as 1.2 centimeter. Hence, the value, substituting all this value, it is given as 15.44 days. So, this is the numerical problem related to consolidation.